All right, transformations. There are 6 paragraphs that we've been using throughout the year that you just got to know. Now, if you forgot yourself for a minute, you could type them into y equals and double check, and that would be a very responsible thing to do. But I think these will come back to you pretty quickly. The absolute value of x, remember, is a v. You know how absolute value has a v, so shouldn't forget that one. The quadratic we've used over and over again is some type of a parabola. This is the graph of x squared. Y equals x is a line that goes through the origin. Looks like this. Y equals x cubed, the squiggle, looks like this. The square root of x is like a little hook coming from the origin. 2 to the x power. Any exponential function, if it's exponential growth, it has an asymptote at y equals 0 and it goes through 1 on the y-axis. If it's decay, of course, then it will go down this way, okay? A logarithm is the inverse of an exponential function, so it goes through 1 on the x-axis and looks like this. Now, 2 that we haven't talked about a whole bunch, but you might encounter, 1 over x looks like this. So you can see where the asymptotes are on that one. And 1 over x squared looks like this. Now, what we get to do with these a lot of times is a transformation. We get to move them up, down, left, right, reflect them. These are things that you must know. Remember that really cool activity with the Velcro that your teachers made for you? Oh yes, well, all this needs to be in your brain and you cannot miss these questions. These should be gimmies, so let's practice a little bit more and make sure that you are ready. If there's a negative in front of x squared here, then it reflects about the x-axis. It's like if I were to fold my paper along the x-axis, it would make my parabola turn upside down. Now, the other thing that could happen is that the negative is in there with x, it reflects over the y-axis. Doesn't always change the graph. In the case of a parabola like x squared, our original looks like this. And if I was to fold my paper in half along the y-axis, it still looks like that. Our next one up here, adding 3 to x squared. Well, if you just add something or subtract something to a function, it moves it up and down. And it's what you would think. Plus goes up, minus goes down. So here when I add 3, my original parabola went to the origin or went through the origin. Now this one is going to be touching the y-axis at 3. X squared minus 3, oh, this one's going to go down. It's going to shift it down 3 spaces and cross at -3. Now, do you see the difference in the next 2 we're about to do? The plus 3 and minus 3 are inside with x. This is a left and right move, and it's opposite of what you might expect. Plus 3 moves it to the left, minus 3 moves it to the right. So my original function goes to the origin. This tells me left 3 spaces. So my parabola now looks like this. On the next one, I'm going to move it from the origin over 3 spaces to the right. Looks something like this. Now, a number out front makes it stretch vertically, so we have a skinny, skinny little parabola. And that's going to happen when whatever's being multiplied out front is bigger than 1. If you have a fraction that's between 0 and 1, then it's going to compress it, or as we say, smush it, to where it looks something like this.